Okay, so we were talking about frequency distributions and histograms. These are ways of organizing and displaying quantitative data, right? So quantitative data is when your variable, the possibilities of your variable are numbers, okay? Like the number of times a person has been on a plane, okay? That would be a quantitative variable. Or a person's weight. So if we looked at a group of people and looked at the weights of those people, that would be a quantitative variable because each individual data point is a number. Okay, so then organizing quantitative data, we said we used frequency distribution. Too big. Okay, so these tables up here are frequency distributions. So we started with single value groupings. So we grouped the data together by just single values. Number of TVs in the house, 0 through 6. So we had a frequency of people in the data set at each one of those single value of the variable. And then we found the relative frequency, which is kind of like looking at that value of the variable, what portion or what percentage of the whole data set was it? Right? Remember that? So that's our single value groupings. Okay? Limit groupings is where we create ranges. And we're going to take all the data values starting at, in this case, starting at 30 up to and including 39. So with limit grouping, you include the lower limit of the class and the upper limit of the class are included in that group. So if there were some investments here whose days to maturity were 39, the upper limit of the class, they belong in that class, 30 to 39. Similarly, in this one, if there was data values that were 79, they go in that class, 70 to 79. That's what limit grouping is. Okay? Then when you have a discrete variable, you use cutpoint groupings. So, continuous variable. Continuous variable is where it could be like any number, including like fine decimals, right? So like when you time someone to run a race, or you're gonna measure the length of something that could vary. Okay? So then you have the lower limit and the upper limit. But the upper limit, when you get to the actual upper limit, then you're in the next higher class. Then that data point lands in the next higher class. Okay? And then, so then we had the frequency and relative frequencies of either each single value or each class. And then we found histograms. Histograms are like bar charts where the heights of the bars correspond to the frequency or relative frequency. And so here's a bar chart for that one there. And with a single value groupings, those are centered up on the bars because each bar is a single value of the variable. And then with limit groupings, so we know like this one here, right here, it's going to be all the investments whose days to maturity were from 70 to 79, including 79. That's this bar right here. So then 80, so the axis scale, or the edges of the bars, represent the lower limit of all the classes. Because the upper limit of the classes is going to fall in that group, and so we use the next class's lower limit to start the new bar. Okay. So what we didn't, we're going to do an example of cutpoint grouping. So let's review what cutpoint grouping is. Again, we're going to do ranges, or we're going to group the data together by ranges. And so the upper class cutpoint, that particular value actually values of the variable that are at the upper class cut point go into the next higher range. Okay? And then the class width, it's the same as for the limit grouping, just it's the difference between cut points. And the class midpoint would be the center, the numerical average of the cut points. Okay? So we'll do this example here. So this is weights in pounds of 37 males aged 18 to 24 years. So we're going to create a frequency and relative frequency distribution and a histogram for each. We're going to use cut point grouping with a class width of 20 with the first lower class cut point of 120 pounds. There was no one less than 120 pounds in here, so that's where we'll start. And then you're going to make your class widths of 20. So then if someone weighed 139.5 pounds, would they be in the first class or the second class? So the first lower class cut point is 120. The class width is going to be 20. So someone that weighs 139.5 pounds, would they be in the first class or the second class? They'd be in the first. They're still in that first range. What about someone who weighs exactly 140 pounds? They get into the second, right? Because that first class will be from 120 up into everything less than 140. And you can write that. So when you write it, you write 120 up to, or you can write less than 140. Because if once a man's weight is exactly 140, even though that's the upper cut point of the first class, they go in the next class. They go in the second class. Okay, so this is basically another good example and a review, lots of review from last class. So get a partner and take 10 minutes to do this. You're going to create the frequency distribution, the relative frequency distribution, and then both histograms. Okay? And you're going to do it according to this, the class widths of 20 and the first lower class cut point of 120. All right, find someone to work with. Yeah, but you need the actual table, right? The table that says the volume of each group. So that's the histogram. But you need that frequency and also distribution too. So the table that allows you to make that. That's it. Yeah. It's actually like the difference. Maybe I should have done this before. Does that help? Anybody have a question? Making progress? Okay, here we go. Here's the frequency and relative frequency. Most of you are at least mostly almost done, right? Check. Check it out. How do we do? Good? I see nods. Good over here? You guys good? Making sense? Okay. How about any questions on the histogram? So I'll just kind of start it, but I'm not going to draw the whole thing. But remember, so then when you draw these bars, that first bar is going to straddle 120 and 140. But we know that if it is 140, you're in the higher class. So I'll just do a rough sketch here. So 120, 140, 160. So that first is going to be 3. So 1, 2, 3. It's going to look like this. Mine's probably a lot wider than yours. I'm just going to do the first 2. Okay? And so we know that there's three guys whose weights were from 120 up to, but not including 140. And then up here somewhere is 9. So then the next bar is going to look like this. That's the best histogram I've sketched all day. Okay? And then this is going to be 9, this shows 9 guys had a weight of 140 up to, but not including 160. And then you keep going. Okay? And then if this was the relative frequency, then this scale would be right here on the scale, this would be 0.81. And on the scale, this would be 0.243. And because it's relative frequency, it's showing the relative amounts of these to each other. You get the exact same shape. The histograms look exactly the same. It's just a different scale. In fact, I've seen it where they've done it this way. They just draw the bars once. And then over here, they have the frequency scale. And over here, so it's the same bars, and over here they have the relative frequency. So you just draw the bars once, and you just put one scale on one side and one scale on the other side, because the way it appears is exactly the same. Okay, questions on cut point grouping or any of this? Frequency, relative frequency, or histograms? Cool, let's move on. If we're good there. So, dot plot. It's so easy, okay? You just put a dot for every data point, and you're going to put it above the value of the variable. So this is a variable. The variable here is the price of DVD players, of 16 DVD players. So the first one in the data set, 210. So we come over here, and we go, boom. That dot means that first, that's one DVD player that costs $210. All right, next one, 224. Boom. So here's what you have to do, though. When you do this, you have to keep the first dot in any particular price, you want it at the same level. And then the second DVD player at that price, you want along the same level. So that we still have a visual, kind of accurate visual representation when we're done. So you don't want to make them, like all the ones that are 210, you don't want to make them really scrunched, and all the ones that are 220 really spread out. Because in the end, we want to see the distribution of the data. Does that make sense? So the first data point in any value of the variable, keep them along the same level. Then second and third. So keep them in horizontal rows. All right, so we're going to have 224 right there. 208. Keep a nice horizontal row there. 212. 219. 219 again. So keep an even spacing. 209 again. Oh no, that's 209 there. 212, there's the second one for 212. Keep it at the same height as the second one for 219. 214. 199. 215. If I make a mistake, stop me. 219, there's a third one. 197. Well, this is a pretty old data set, huh? What are DVD players like now? Like 30 or 40 bucks? Do people buy them anymore? All right, what was that one? 197, 199 again. And 210 again. So when you're done with a dot plot, you get the same kind of effect as a histogram because it gives you a visual view of what the data's like. Did I miss one? One what? There's another 199. There are three of them? Yeah, you're right. Thank you. Am I good now? All right, so then here we go. Is that what we came up with? All right, so then this is a visual representation then, just like a histogram is. You see where the data is lying, right? We've kind of centralized here around 210. But then we have you know, these expensive, a group of expensive ones, a group of cheaper ones over here. So you gotta get a visual sense of what the data is like, just like a histogram. That's a dot plot. So these are useful for like comparing. You might have like 2 or more dot plots stacked up vertically, and then you can use those to compare data sets to one another visually without having, so like if you had a bunch of tables and numbers like this, it'd be really hard to get a feel for how those different data sets compare. But if you had a bunch of dot plots, then you really get a sense of what the data is like and how each data set compares to one another. Okay? Questions on dot plots? All right, next. Stem and leaf diagram. Okay, so here's this is the 40 short-term investments, the days to maturity. We saw that data set before. Okay, a stem and leaf plot is where this is called the stem. And the stem is going to be all the digits up to the last digit. Okay, so in this particular data set, the stem represent the tens. The stem in this case is the tens place. This is 30, 40, 50, 60, 70, 80, 90. Okay, and then our leaves, so each stem has 1 or more leaves, or it doesn't have to have 1, in fact, it can 0 or more leaves, and each leaf then is, in this case, is the ones place. So this is showing 3 data values, 38, 36, and 39. So we see those here, 38, 36, and 39. So those 3 data values are shown in that first row. The stem is saying these are in the 30s, 38, 36, 39. And so then we have 85, 89, 81, 87, 80, 83, 86. Okay, then they reorganized it. They put then the data in order by ones place in the second one. So this just helps to identify, like, look, there's 3 70s. You can't see that as easily here. Oh, there's 3 70s, and there's 2 64s. Notice also this. Do you see how this also is like a histogram or a dot plot? How is it like a histogram or a dot plot? Right. Let's see. Let's try. All right, I can't do it. All right, anyway. Yeah, so it's like on its side, right? So you can see this kind of shape of the distribution. So if you think of flipping it up on its side, it's having the same effect as a dot plot or a histogram, showing us the nature of the data set. Okay, so another thing they'll do is, let me see it exactly here. 2 lines per stem. So what this is called 1 line per stem. So the stem is 3. We're going to put all the 30s, 30 days, in the same line. But another way you can do this is you can come over here and you can say, all right, what I want to do is I want to group. I'm going to do 2 lines for each stem, and then the first line will be 0 through 4, and the second line will be 5 through 9. Okay, so what will I have here? So nothing, right? And then what will I have here? 6, 8, 9. How about here? Nothing. 7. Okay, and then here I'll have 0, 1, 1, 3, and then 5 I'll have, second one, 5, 5, 6, 7. 0, 2, 3, 4, 4, 5, 6, 7, 8, 9. So by doing it this way, you can kind of get now, you're getting a more specific view by spreading it out this way. Then you get kind of, it's like a more detailed visual representation of what the data set looks like. You may be able to see things here about the data set that you couldn't see here by just looking at how far the list of numbers comes out, or the leaves, right? These are the leaves. Does the stem and leaf make sense? Make sense? Any questions on that? So there's practice here. Next one. Okay, so looking at this data set, what will your stems be? What will your stems be? What will the first stem be? $20? 1? 19. The first stem will be 19 because your leaves will always be whatever your leftmost place is. So if this was 21.3, then your leaves would be the 10th place. Those would be your leaves. So your leaves is always your rightmost place. In this case, that's the ones place. So then the stem would be everything else. Okay? So in this case, the stems are 2-digit numbers. And your first stem is going to be 19. Okay. So cool. Do it fast. Do it fast so we can. And let's just do B. Can we just go right to B for time's sake? So see if you just start off, just do 2 lines per stem right away. Instead of making both of them. If you can do 2 lines per stem, you can certainly do 1 line per stem. So let's just do part B. Break up the work. So team up with your partner so you're only each doing half. Is that what you got for the first 2 lines? Let me just do this by hand first. So when you're going to have the 20, we're going to have the 0 through 4, 0 through 4, and then 5 through 9. So you can just come down here. So there's an 8, so throw an 8 in there. There's a 2. There's a 9 and a 7. 2, a 0. 8 and 3. So I think, and then if we wanted to, we could put those in order like we did on the last slide. Do I have the 20s right? And then is 21 the last two lines? Is there any 22s? Oh, there's one 22? Right there. So 21, first line, second line, and then 22. Is this what you got? Does this make sense? All right, again, distribution, right? So what we're going to talk about next is different shapes of distributions. So you're probably all familiar with this idea of the bell curve, right? Bell curve. Where most of the data is in the center of the distribution. So this is kind of like a bell curve. Do you see that? This is kind of like a bell curve. I think this one. There we go. There we go. Okay, so turn it up on its side, and you get a bell curve. So then we're going to talk about symmetry. So does this bell curve have symmetry? So let's see here. If I can kind of sketch it. Is it symmetric about the center? Not really, right? And so which way is the data skewed? So what we mean is we've got, this is like the center of the bell, but where would the actual average be? Would the average be to the right of where the bell is, the top of the bell, or to the left of where the top of the bell is? That's how you know how it's skewed. So is this one right skewed or left skewed? Left skewed, because you've got more data down here that's going to pull the average to the left away from the center of the bell. So this one's left skewed. Does that make sense? So why this is a little bit confusing is you look at the data and you see the top of the bell and you say, oh, the top of the bell is more to the right. And so you think maybe this is right skewed, but that's not what it is. The skew is talking about where the average is relative to the top of the bell. Where is the average relative to the top of the bell? That's what the skew is. The average is going to be pulled down by all this data here. So it's going to be, this is left skewed. So when you have a big data set, so this is heights of women, something hundreds of women, okay? And so when you have a large enough data set and the right kind of data set, like height, you get the bell curve, all right? So this is our bell curve type shape of the distribution, and this is symmetric, right? So here's some other types of, so there's our bell shape. Then we have triangular, and then uniform. Uniform means we have an even distribution, uniform distribution of, oh shoot, time's up. This is fast though, okay? So uniform is even distribution of all the values of the variables. Reverse J shape, looks like a J. Here's our right skew, right? There's the hump, but the average is going to be pulled to the right by the fact that we have more data out here that's higher. So that average is going to be pulled to the right, right skewed, left skewed. So then the mode is where most of the data is. So this is bimodal because we have two places where there's a concentration of data, and then multimodal. So let's just practice quick. Left or right skewed? Right skewed. Right skewed because the average will be pulled to the right of the top of the bell.